out. So, all right, so let's go ahead and do that. And let me get my pen here. And guys, as I'm going through this stuff here, if y'all have any questions as I'm going through it, you know, turn on your mic and say, sir, can you go over that part again or whatever, you know. I want to try to make this as similar to as if we would be in class as possible, okay? So when we're in class, if you guys got questions, you know, I always tell my students, hey, let me know if something that I didn't make sense, and I'm more than happy to go over it again. Okay, so 3.1 here is quadratic functions and models. And it says the quadratic function f of x equals ax squared plus bx plus c can be written in this form right here. So this form right here, guys, this is typically what we call vertex form. Okay, so there we go, vertex form. And where the value of h and the value of k is going to give us the vertex of the parabola, okay? So all these graphs are going to have a similar shape. They're all going to either open up or they're going to open down. And the vertex is either going to be the lowest part of the graph or it'll be the highest part of the graph. And that h and k are going to be the coordinates of our vertex, okay? That's what that means. Oh, come on. There we go. Okay, so it says the graph of f has the following characteristics. It's a parabola with a vertex h and k, and there's something called the vertical line x equals h is the axis. We call it the axis of symmetry. In essence, what that is it's the vertical line that cuts the graph directly in half, right? It's kind of like a mirror. So it's going to cut that graph directly in half. Whatever you see on the left side, the right side is going to look the same. And okay, then the next part here, number 2 says, if a is greater than 0, the graph is going to open up. And if a is less than 0, then the graph is going to open down. What that means is if the number a is positive, the graph will open up. And if the number a is negative, then the graph's going to open down, okay? And it says it is wider than the graph of y equals x squared if the absolute value of a is less than 1, and it's narrower if the absolute value of a is greater than 1. Okay, so what this means here, whatever that number a is, okay, if the number a is the absolute value of it is smaller than 1, what that means is if it's a number like 1/2 or 1/3 or 0.2, something like that, the graph is going to be wide. Okay, it's going to look more like that. Okay, and if the number a is like a +3 or a -2, something like that, the graph is going to be real narrow. Whether it opens up or down, it'll just be more narrow. Okay, let's see. The y-intercept is always going to be the point 0 and c, and you might say, where's c coming from? That's the number c right there. And then we have something called the x-intercepts, and it says the x-intercepts are found by solving the equation. And when we take this equation here and we set it equal to 0, I'm going to explain how we're going to do this part in a minute. Let's see. Okay, then the next thing is this part right here. So this piece of information is what we call the discriminant. It's the number that's on, if you remember from the quadratic formula, this number right here, guys, is the number on the inside of the square root, okay? All it's saying is if the number on the inside of the square root is positive, greater than 0 means positive. If it's positive, we're going to have 2 x-intercepts, okay? If the number on the inside of the square root is actually equal to 0, we're going to have 1 x-intercept, and this is going to be it right here. And if the number inside the square root is less than 0, meaning it's negative, we're not going to have any x-intercepts, okay? So the directions here for this first part to say match the equation in 1 with the description in 2. Okay, so first thing I'm going to do, I'm going to write down my formula, y equals a x minus h squared plus k. So first thing is my vertex is always the point h and k. I want you to notice something right here. If you notice here on the inside, we have a negative. Here we don't. all that means is whatever you sign you have inside here, if it's negative, we're going to change it. We're going to make it positive. And if it was positive, then we're going to make it negative. The last number here, that sign stays the same, okay? And then the other thing I wanted to mention, remember, if A is a positive number, the graph opens up, and if A is a negative number, the graph opens down. So first thing I'm going to do a little stare and compare. I'm going to look at this problem right here, and I'm going to look at this piece right here. So remember, my vertex, whatever sign I have in here, has to change. So if I see a positive 4, it's going to be a negative 4. The second number, that sign does not change. So my vertex is a negative 4 and a positive 2. So that's telling me it's either going to be C or D, okay? And then remember, the number A is the number in front of those parentheses. And we said if the number A is positive, the graph opens up. And if the number A is negative, then the graph opens down. So when I look at this piece here, that number is positive, so the graph's opening up. So this one here matches with C, okay? I'm going to do the same thing for the second one. I'm going to do a little stare and compare. So I'm going to look at this piece here, okay? We're going to find our vertex. So we're going to change this sign. That's a negative 2. This one is going to stay the same, positive 4. So the first one always changes. The second one stays the same. And then again, I'm going to look at the number in front here. And since that number is positive, that graph's going to open up. So I'm going to look for vertex of negative 2, 4 opening up. That's going to be matched with A. Okay. All right. So let's see if we can do the same thing for the third one. So the third one, my vertex, negative 4 and positive 2. And because of this piece, that graph's going to open down. So negative 4 and positive 2 opening down, that one's going to get matched with D. And then, so it looks like the last one's going to have to go with B, but let's just double check it. So my vertex, again, negative 2, positive 4. Yes, that's negative. So it matches with the last one. Okay. So in essence, that's all I'm really trying to do for that problem there. And your first problem, guys, that y'all have in your homework for 3.1 is this type of problem right here. And I did send a video out for it last week. So if you just kind of go through the messages, whether it's on Pronto or on Remind, you'll see a YouTube video that I sent out, and it's basically the same problem. Okay, so let me scroll down a little bit, see if we can do the next part. Okay, so this next problem here says, consider the graph of each quadratic equation. Do the following. Part A says we're going to find the domain and the range. Part B says we're going to find the coordinates of the vertex. Part C says we're going to give the equation of the axis. D says we're going to find the y-intercept. Part E says we're going to find the x-intercepts. Okay, so let's go ahead and do that and see if we can't figure this out. So let me see, let me come back here. Okay, so for part A, get my pen going, part A. So the one thing I want to mention about the domain, for any polynomial function, guys, the domain is always going to be all real numbers, okay? It's always going to be from negative infinity to infinity, okay? Now, we're going to do the range. So remember, the domain refers to the x values. The range refers to the y values, right? Okay, so here's my y-axis. And when I'm thinking about the range, when we think about the domain, we go on the x-axis. I'm just going to do this in red, and then I'll erase it a little bit. But we always go from the smallest number to the biggest. So I'm going from the left to the right when I'm talking about the domain. When I'm talking about the range, we go from the bottom to the top. Okay, so I'm going up and down. So the first thing I might say is, what is the lowest point in our graph that we have? Oh, we at negative 4. And every time I keep going up, if I were to move to the left, I would hit my graph. And no matter how high up, if I go to the left, that graph, remember, that graph goes and up forever and ever and ever, right? So no matter how high I go up on my y-axis, whether I move to my left or whether I move to my right, at some point, I'm always going to hit that graph, right? Let me get my eraser and clean this up. Okay, so I know that my range starts at -4. So this is telling me that y is bigger than or equal to -4. And if I were to think about this in terms of an interval from -4 all the way to infinity, okay? All right, so there's my domain and my range. Now part B says, give the coordinates of the vertex. So guys, look, here's the equation, right? Here's the equation. So remember, my vertex, this sign is going to change. That one will stay the same. Oops. So my vertex is going to be the point -3 and -4. Okay. Then we're going to do part C. Part C says we're going to find the equation of the axis. Okay. The axis, it's always going to be a vertical line, and vertical lines always have the form x equals some number. And you might say, what's that number? Remember, the axis is, let's see if I can make this a little thicker. There we go. The axis is the line that cuts the graph in half. Well, look at where it passes through. It passes at -3. It's always going to be that same number right there. Whatever the x coordinate of my vertex is, that will be the same value on my axis. Okay. Now part D says we're going to find the y-intercept. Okay. So the way I'm going to find the y-intercept is I'm going to plug in 0 for x, and we're going to figure out what we're going to get for y. What I mean by that, guys, is I'm going to take this equation right here, and everywhere I have an x, I'm now going to plug in the number 0. So 0 plus 3 squared minus 4. Okay, so 0 plus 3 is still 3 squared minus 4. 3 squared is 9. 9 minus 4 is 5. So there's my coordinates of my y-intercept. Okay, and then finally E says let's find the x-intercepts. Okay, so remember what the x-intercepts are. The x-intercepts are the points on the graph where the graph hits my x-axis. So if I look at my graph right here, and I say, hey, look, it's hitting the x-axis right here, and it's hitting the x-axis right there. So what are those values? Well, this value here looks like to be -1, and this one appears to be -5. So when x is -1, and when x is -5. Now, it's probably going to ask me to write them as points, okay? So remember, as a point, each of these are going to be -1 and 0, and -5 and 0, because those would be the coordinates of those points. So before I go on, let me see. Before I go on, does anybody have any questions on how I did that particular problem? Is it making sense as I went through it? Like, are you guys able to follow along, I guess is my question?
Yeah, with that one, yeah.
Okay, good.
No.
Good. Yeah, Fabian, are we okay? Fabian, I don't know if you can hear me. If you can turn on your mic, or you can even put it in the chat if you want to. I just want to make sure we're doing okay. So guys, I'm going to go ahead and come back to the same thing, and I'm going to continue doing what we're doing. Again, guys, at any point in time, if I'm doing something and it doesn't make sense, just turn on your mic and say, sir, can you do that part again? I'm happy to go over it again, okay? All right, so look, this problem here, almost identical to the one we did. We're going to do the same steps. The only thing that's different is, the graph that we have and the equation that we have, but the process is going to be the same, okay? So part A, we're going to find the domain and the range. So remember, the domain, this should always be the easiest part because the answer is always going to be the same. The domain is always going to be -infinity to infinity. What the domain is are what values, if I go onto the x-axis, will I always find a y value? And the answer is yes, right? So like if I were to pick, say, this point right here, this point on the x-axis, if I were to go down, would I hit my graph? Eventually I would, right? If I keep going down, I know that graph's going to do this, we're going to hit it. And no matter how far to the left I pick a point or how far to the right I pick a point, if I go down far enough, I'm eventually going to hit my graph. In essence, that's what the domain refers to, okay? So now let's find the range. So remember what we said, the range refers to the y values, right? In terms of the y values, we're always going to start from the bottom and we're going to work our way from the top. So if I'm coming up this way on my y-axis, if I'm moving to the left, I'm hitting my graph. No matter how far down I'm going to go, because that graph goes down and down forever, as long as I move to my left, I'm going to hit my graph. And at some point, I'm going to stop. Right here is where we're going to stop. So we're going to go from negative infinity to a -2. Now, sometimes people say, why don't you go from -2 to a negative infinity? Because I always go from the smallest one to the biggest one. So I'm always going from the bottom to the top, okay? So let me get my pen going. Sometimes it freezes up on me, guys. So if you hear a little hit, I'm hitting the pen to get it to work again. Okay, now part B. Let's find the equations of the vertex, okay? So we're going to find our vertex. So the vertex, remember, we're going to change that sign. We're going to leave this one alone. -3, +2. Okay. Part C, we're going to find the equation of the axis. Remember, it's always going to be that same number, x equals, and in this case, -3. That is the line that cuts the graph directly in half. Okay. Part D is in dog. We're going to find the y-intercept. So remember, the way we find the y-intercept is we plug in 0. So we're going to get a point 0 something, right? So I'm going to come back to this equation right here. And everywhere I have an x, I'm going to plug in the number 0. Okay. And so let's see. This is -2. 0 plus 3 is still 3 squared plus 2. Okay. Now, guys, when I'm doing this part right here, remember, I got to do order of operations. So I got to do my exponent first. So -3 squared, I'm sorry, 3 squared is 9. So this is -2 times 9 plus 2. Okay. Now I got to multiply the -2 and the 9. And that's going to give me a -18 plus 2, which is a -16. So there's my y-intercept, right? It's going to hit it all the way down here at wherever -16 is. That's where the graph's going to cross through. Okay. And then, let's see, that was part D. So part E says we're going to find the x-intercepts. Okay. So the x-intercepts are always going to be those points right there. Okay. So if I think about it, here's 0, this is -1, that's -2, -3, -4. So these numbers right here, -2, 0, and -4, 0, right? Those are going to be the coordinates of those two red dots. And so again, if I notice this problem here, very similar to the one we just did, the process and how I did it was the same way. And it's just a matter of using the equation of the function that they give me. Oops. And obviously using the graph, right? Using the graph. Okay, so I'm going to kind of keep scrolling on here, and we're going to see if we can answer some of these questions here. So it says, given the graph of y equals f of x, answer the following questions. Okay, it says, what's the minimum value of f of x? What they're asking me here, what's the lowest point on the y-axis? That's what they're referring to, okay? So when I'm doing this problem here and it says, what's the minimum graph or the minimum value? What's the lowest point? The lowest value that my graph hits at is at f of x. Oops. F of x, come on, is equal to 3. Okay. Then the second part says, for what x value is f of x as small as possible. All they're saying is in this low point right here, what is the x value there? Well, we're going to say, well, the x value happens to be at -3. Okay. Now, the third question says, how many real solutions are there to the equation f of x equals 1? So, oops, get my eraser. Okay, so let me explain what they mean by that. So f of x equals 1, that means y is equal to 1. So what they want me to do is they want me to draw a line, a horizontal line, at y equals 1. And the question says, when it says how many real solutions are there to the equation f of x equals 1, they're asking us how many times does this graph hit that line? And you look at the picture and you say, well, it doesn't. So that would mean that there are 0 real solutions to it, okay? And then the part D, or the last part, says how many real solutions are there to the equation for f of x equals 4? So this is 3, this one's going to be 4. I'm going to do the same thing. I'm going to draw a horizontal line. And we're going to say, okay, how many times does this graph here hit this line? And you look at the picture and you're going to say, well, it hits it twice, okay? That's what they mean by when they're saying how many real solutions are there. When they're asking me how many real solutions are there to f of x equals 1 or f of x equals 4, in essence, what they're asking me is, can you tell me how many times would that graph hit a line horizontal at, at 1 or at 4 or whatever number they happen to give me, okay? So guys, one of the things I'm trying to do with this here is explain it in terms that we can understand as well. Because sometimes, you read that question and we're not exactly certain what they're asking me to do. That's what they're asking me to do. Okay, so now here's another problem, very similar to what we were doing before. And it says several graphs of the quadratic function f of x equals ax squared plus bx plus c are shown below. For the given restrictions on A, B, and C, select the corresponding graph from choices A through F. And it says, hint, use a discriminant. So the first thing I'm going to do before I look at these problems, I'm going to scroll back to the very, very top when we first started talking about this business here. And I'm just going to I'm going to circle it, and then I'm going to write it down again a little bit later so you can see what I'm talking about. This thing right here is what we were referring to earlier, the discriminant, okay? And it's this b squared minus 4ac, okay? So I'm gonna use this idea right here. I'm gonna rewrite it for these problems so that we can kind of figure out what's happening, okay? That's what they mean by the discriminant. So let me scroll a little more. Here we go. Okay, so this number here, b squared minus 4ac, we have 3 possible solutions for it, okay? Number 1, if that number is greater than 0, meaning it's positive, okay, that means we're going to have 2 X-intercepts, okay? Second possibility, suppose it's actually equal to 0, then we're going to have 1 X-intercept. And number 3, if it's less than 0, meaning it's negative, we're going to have no X-intercepts, okay? So now, what I'm going to do here is I'm going to look at, say, 41, okay? First thing it tells me, the number A is negative. So remember, I'm going to draw this, I'm going to write this part over here again. So A is less than 0 and A is greater than 0. When it's less than 0, the graph opens down. When it's greater than 0 or positive, then my graph opens up. Okay, so the first part here, 41, tells me it's less than 0, tells me my graph is opening down. So it's got to be D, E, or F, right? It's got to be one of those there. And let's see. When I look at 41, it's got to be D, E, or F. The second thing it tells me is that my discriminant is equal to 0. When it's equal to 0, I have 1 X-intercept. So when I look at graphs D, E, and F, I have to ask myself, which one of those graphs, D, E, and F, hits the axis the x-axis only one time, right here. So that's 41, right? And then I'm going to do the same thing here. I'm going to go to 42, okay? And first thing it tells me A is greater than 0. So now it's telling me it's got to be A, B, or C because the graph's going to open up. And then so it's got to be one of those there. And then if I look at this part right here, less than 0, right? When it's less than 0, remember, I don't have any x-intercepts. So when the graph's going to open up and I don't have any x-intercepts, it's got to be choice A because this one here is opening up and it never hits the x-axis, right? Okay, so let's do the same thing for 43. 43, okay, less than 0. So again, it's got to be D or F now. And my discriminant is less than 0. So if my discriminant is less than 0, negative, there's no x-intercepts, this here has to be number 43. And then I'm going to look at 44, okay, and it says, look, A is less than 0. That's negative. It's got to be F because that's the only other one that's going to that I can choose from. But it tells me my discriminant is positive. When my discriminant is positive, we have 2 x-intercepts. So this one here is going to be 44. And then finally, 45. When I look at number 45, let's see, it's positive. And my discriminant is also positive. When my discriminant is positive, we're going to have 2 x-intercepts. This one here should be 45. And then so 46 should be choice B. It's opening up, and there's only 1 x-intercept. So this one here is number 46. So let me see. Before I do anything else, did that seem to make sense how I did that part right there, guys? Anybody have any questions in regards to what we just covered before I go on? We're good so far? Okay, so let me keep going here. Give me 1 second. Let me see, where's my thing? Here we go. Let's share the screen, come back. Okay. All right, so now this problem here is asking me to find the equation of the parabola in vertex form with the given graphs. Okay, so remember, my form looks like this. F of x equals a x minus h squared plus k. So the first thing is when I look at my picture here, I already know that this here, guys, is my vertex. I know that's my h and that's my k. So the first thing I'm going to do is I'm going to write f of x equals a x minus the number 2 squared, and then my number k is the number -1, so I'm going to put a -1 right there. Okay. Now the other thing that we know is on this particular graph we have this point labeled, and that point is 0, 0. Remember, every point is always in the form x and y. So the x number here is 0, and the y number is also 0. So guys, just a reminder, f of x, that's the same thing as y. And it's telling me that in this value, y is 0. And we already knew that x was also 0. So what I need to do now is I need to find the value of my number a. So I'm going to leave this 0 alone right here. Let's see, 0 minus 2 is a -2 squared minus 1. Okay. -2 when I square it is going to give me a +4 minus 1. I'm trying to solve for a. So I'm going to take this -1 and I'm going to bring it over to the other side. That's going to give me a +1 equals a 4a. So I'm going to go ahead and divide both sides by the number 4. And I'm coming up with a equals 1/4. Okay. So now that we have that part, we can go ahead and write out our equation. F of x equals the number a that we just found, 1/4 x. I'm going to leave that minus 2 squared minus 1. And there's my equation. Okay. Guys, I want you to notice this graph was, let me see, that graph right there was opening upward, and the number A that we came up with, positive number, right? So that's telling me that I'm probably on the right track as I'm doing this thing here. Okay. Let's take a look at the next one. We're going to go about it exactly the same way. Okay. So first thing I'm going to do, I'm going to write down my equation, right? Y equals A x minus h squared plus k, right? So guys, remember, whether I write y or whether I write f of x, it's the same thing, okay? And so here's my vertex, -2 and +3. Okay, so y equals A. Notice, if it has a -2 here, I need to write an x plus 2, right? Because we said we're always got to change that sign. If this one here is a +3, it stays the same, okay? All right, now we're going to do the same thing we did before. I'm going to use this point right here. Remember, that point is written in the form x and y. So x is the number 0, and y is the number -1. So right here, I'm going to put a -1 equals A, oops, oh, come on, pen, 0 plus 2 squared plus 3. And what I want to do here, I want to solve for the letter A, okay? So -1 equals A, 0 plus 2 is still 2 squared plus 3, okay? So -1 equals, let's see, 2 squared is 4, so that becomes a 4A plus 3. I'm going to go ahead and minus 3 on both sides. So -1 and -3 is a -4 equals a 4A. And then when I divide both sides by 4, I'm getting A equals -1. Okay, so now that I got A equals -1, oops, I can go ahead and write out my equation. Okay, so my equation is going to look like this. Y equals A, -1. I'm just going to put a negative. X, we already have it right here. So all I'm doing is just using this part right here, and I'm just filling in the A. Plus 2 squared plus 3. Notice the graph that we had, guys, that graph was opening down. And if you notice, our number A was negative. Hold on. Okay, so we're going to do the same type of thing here. Same types of problems, guys. Okay, let's take a look. All right, so I'm going to write out my equation. Y equals, oops, x minus h squared plus k. Okay, here's my vertex, 1 and 4. So y equals x, remember, -1 squared and plus 4. Okay, so now that we got that part, then we're going to use this point right here. That's my x and my y, okay, to find the value of A. So the y number happens to be 2. My x number is still 0. Okay, and I'm going to go ahead and start solving. So 2 equals A, let's see, 0 minus 1 is a -1, but that's going to be squared plus 4. So let me get the pen a little bit bigger. Okay, so here we go. Oops. 2 equals -1 squared is a +1, so this is a 1A plus 4. So I'm going to go -4 now, -4 on both sides. So this is a -2 equals 1A is the same thing as A. So notice A is negative, right? Look at our graph. Our graph is opening downward. All I'm going to do now, guys, is take this equation right here and just substitute that part where the A is equal to 2. So we're going to write y equals negative 2 x minus 1 squared and plus 4. So let me see. Before I go on to the next one, let me double check with you guys to see. Oops. How does this stuff seem that we're doing so far? Are we doing okay?
Yeah, I got
You
it.
guys, you got it? Okay. All right. So guys, let me ask you a question. Do you want me to do the next? I mean, the next problem is pretty much the same type of problem. Do you want me to do that one, or do you want me to kind of skip over it and move on to something else? What do you guys think?
I mean, I'm okay without it, but if other people
Okay.
need it, then that's okay.
Okay. Let's see. I tell you what. I think Jose Mejia, I like your idea. Let's go ahead and skip that one. Skip the next one, guys, and then and go on to something different. So this part right here, guys. I just kind of, when you watch the YouTube video, this problem here is basically the same kind of problem, right? And it's just kind of a cool little thing. It's a guy who gets shot out of a cannon, and we come up with the equation that describes his path. But it's, you know, you don't have a problem like that in your homework. It was just kind of a neat little thing. I'll let you guys watch that YouTube video so that you can see what it's all about. So let's go ahead and do a little bit of 3.2. I just need to check one thing, guys. Give me 1 second. I'll be right back. All right, so guys, I'm back. I was just getting a little bit of water. So I want to do a little bit of 3.2 with you guys because we still got about 15 minutes or so. So I want to do a little bit of 3.2 because I think this will help, you know, and again, I don't know if you guys have already, you know, these two sections are due by tomorrow night. So I don't know if you guys have had a chance to work on them yet. If you have, great. If you haven't, then hopefully this has given you enough information so that when you know, get started on your homework, you kind of have an idea of what to do. Okay. So 3.2 is something called synthetic division, and there's something here called the division algorithm. And I'm going to explain the division algorithm to you guys in a real simple way. Okay, so a real simple way says, if you look at all this stuff here, f of x equals g of x times q of x plus r of x. Easiest way to think about this. Suppose I were to take the number 9 and I were to divide it by 2. Okay, and we would do it like we did back in, you know, like 3rd grade or 4th grade, whenever we did this kind of stuff, and we'd say, well, look, 2 goes into 9 4 times, we get 8, we subtract, we have a remainder of 1. And then you would say, okay, well, how do you check your answer? How do you know that 2 goes into 9 4 times with a remainder of 1? And you would say something like, well, because 9 is the same thing as 2 times 4 plus 1. That is in essence what this is telling me right here. This guy right here, f of x, that's kind of like my number 9. The g of x is kind of like my number 2. The q of x is my 4. And the r of x, think about a remainder, is my 1. That's really what it's telling me here. Okay, so these problems here are saying we're going to use something called synthetic division to divide this out. So I'm going to show you how synthetic division works and why it works, okay? So the reason why it works is if we were to divide this out, so I'm going to write the problem down, x to the 3rd plus 3x squared plus 11x plus 9, right? And if I were to divide this like old school way by x plus 1, and what I would, in essence, what I would do is I would say, look, here I have an x to the 3rd and here I have an x. So I would have to ask myself, what do I need to multiply x by so that I would get x to the third? And we would say, oh, you know what? We got to multiply it by, oops, we got to multiply it by an x squared, because x squared times x, that gives me x to the third, and x squared times 1 gives me a plus 1x squared. And if you remember, guys, what we did right here, remember we subtracted? So we say, oh, like, you know what? I got to subtract this. So I'm going to put a minus sign right there, but I got to change that one too so I can subtract. And we'd say, look, x to the third and x to the third, those cancel out. And 3x squared minus 1x squared gives me 2x squared. And then I would just bring down the next piece. I'd put a plus 11x, right? And then I would play this game all over again. So I would say, look, I have a 2x squared, oops, I have a 2x squared right here, and I have an x here. So what do I need to multiply x by so that I get a 2x squared? And you'd say, oh, you know what? We got to multiply it by a 2x, because 2x times x would give me 2x squared, and 2x times 1 would give me a plus 2x, right? And then we say, oh, look, we got to subtract that. We got to subtract that. So these guys are going to cancel out. And 11x minus 2x would give me a 9x. And then I got to bring down my plus 9, okay? And then I'm going to do this even one more time, and I'm going to say, look, what do I got to multiply 9x by, or I'm sorry, what do I got to multiply x by to get a 9x? And you'd say, oh, just a 9. So 9 times x would give me a 9x, and 9 times 1 would give me a 9. And we would subtract them both, and we'd end up with 0, right? So that would be, this is how I would do it. And this is not synthetic division. This is long division, right? But you can see how this process can take a really, really long time. So instead of us doing it this way, and I want you to look at the answer that I came up with. I came up with x squared plus 2x plus 9. We're going to use something called synthetic division, okay? So the way synthetic division works is I'm going to put like this upside down box right here, okay? And instead of me writing every single one of these pieces here, I'm just going to write the numbers. What I mean by the numbers is the number in front of this x to the third is a 1. The number in front of this x squared is a 3. The number in front of that x is an 11. And the number in front of that, this piece here is just a 9. And then I'm going to look at this piece right here. And because it's an x plus 1, do you remember when we were subtracting, we kept on having to change our signs? So we're going to change our sign to begin with. If it's a plus 1, I'm going to put a minus 1 out here, okay? And what I'm going to do now is, first step says, this guy just drops down. 1 is going to stay right there, okay? And then I'm going to multiply. -1 times 1 gives me -1, and I'm going to add straight down. 3 minus 1 is going to give me a 2. And I'm going to multiply again. -1 times 2, -2. And I'm going to add straight down. 11 minus 2 is 9. And I'm going to multiply again. -1 times 9 is a -9. And I'm going to add straight down, and that's a 0. This last number here, guys, is always going to be my remainder. If you remember when we did our problem before, oops, let me see. I heard something in the chat. Let's see. Let's come here. So Vivian, yes, I am sharing the screen. Can the rest of you guys see it? Can the rest of you guys see? Yeah.
Yeah,
okay,
I can.
Okay, so Vivian, you might need to refresh your page because I am sharing the screen right now. So let's see. Let me get back to our problem. Okay, so guys, this last number here is the remainder. All right. If you think about the problem that we had, right? We used to have a, let me clean this up a little bit. We used to have an x to the third problem, right? Because we divided it by an x polynomial. In essence, what we did is we reduced our polynomial by 1 degree. What I mean by that is this number right here, that's the number in front of my x squared. This number right here, that's the number in front of my x. And this number right here is my constant number. So we're left with x squared plus 2x plus 9. And if you notice what we had earlier, guys, when we did it the long way, we came up with exactly the same thing, x squared plus 2x plus 9. The idea is synthetic division works a whole lot faster. Guys, give me one quick second. I got a cat. He just walked in and he wants to eat. So let me give him something to eat and I'll come right back to our problem. Hold on. Leave it there. All right, guys, I'm back. Sorry about that. Okay, so look, I'm going to do the same thing for the next problem. I'm going to use synthetic division to do this problem here. Okay, so first step, we're always going to draw this kind of inverted box. Excuse me. And I'm going to write the numbers, the coefficients of each of those terms. So 5, 5, 2. The next one is a -1, and then a -3. Let me get rid of all this other stuff because we don't need it anymore. Okay. And my number here, if it's on the inside, if it's a +1, I got to change my sign to a -1. Okay. All right. First step, we always bring the first number straight down. So that 5 goes right here. Then we start to multiply. So -1 times 5, -5. Add straight down, that's a 0. Multiply it again. -1 times 0 is 0. Add straight down, that's a 2. Multiply it again. -1 times 2 is a -2. Add it straight down, that's a -3. Multiply it again. -1 times -3 is a +3. Add it straight down, that's a 0. The last number will always be my remainder. For these two problems that we've just done, my remainders happen to be 0. My remainder won't always be 0, but it's 0 right now, okay? So remember what we had. We had an x to the 4th polynomial. So all these numbers they're my coefficients, but they're reduced by 1. What I mean by that is this is now the number in front of my x to the 3rd. We don't have an x squared part, but we do have an x, and then we have a -3, okay? So let's go ahead and do the next one. We'll do it the same way, okay? So look, here's my half box. 1, 4, 2, 9, 4. My sign right here, if it's a +4, got to change it. Always got to change it, okay? -4. So now let's go ahead and start off. First number, always bring it down. -4 times 1, -4. Add them together, we get 0. We multiply again. -4 times 0 is 0. Add straight down, we get 2. We multiply again. -4 times 2, -8. Add straight down, that's 1. -4 times 1, that's -4. Add straight down, that's 0. So again, so far, the first 3 problems have been nice and pretty. My remainders have been giving me 0, okay? So remember, this used to be an x to the 4th polynomial, so we reduced the power by 1. That's my number in front of the x to the 3rd. Because this is a 0, we don't have a number in front of the x squared, but we do got a 2x, and we do got a +1, okay? All right, so let's try the next one. This one looks a little messy. The process is still going to be the same, okay? So I'm not going to change anything here, y'all. Okay, that's still a -9, an 8, a -7, oops, a -7, and a +2. Remember what we said we're going to do with this number? We're going to change the sign. So it's a -2, so on the outside I'm going to put a +2, okay? First step, remember, bring this number down. Always bring that number down, okay? Now we're going to multiply. 2 times -9, -18. Add them together, that's a -10. We're going to multiply again. 2 times -10 is a -20. We're going to add them together. Negative 27. We're going to multiply 2 times negative 27. Negative 54. We're going to add them together. Negative 52. Okay, so the first thing I notice here, my numbers don't look so pretty, but that's okay. And the other thing I notice is my remainder is not 0. Okay, so let's just remind ourselves that's my remainder. Okay, guys, remember what we used to have? We used to have an x to the third polynomial, and we've reduced that power by 1. So now this is a negative 9x squared. This is a negative 10x. This is a negative 27. Now, what I'm going to do with this part here, I'm going to write it as a minus 52 divided by, and I'm going to explain what I mean by that, okay? Divided by x minus 2. So we can even put a little plus right here. This ends up being my entire answer. And you might say, like, whoa, why is that? Why is that the entire answer? Why do we have it that way? So earlier, if you remember when we took 9 and we divided it by 2, and we would say, look, that goes in, oops, that goes in 4 times with 8 and the remainder 1. So wouldn't we say that, you know, we could say it's 2 times 4 remainder 1, but couldn't we also say that that's the same thing as 4.5? Like 9 divided by 2 is 4.5. And when we say 9 divided by 2 is 4.5, that 4.5 doesn't mean 4 times 1/2. It really means 4 plus 1/2. Look what I was dividing by here. I was dividing by 2, so I put my 2 over here. If you notice in this problem, we were dividing by x minus 2, so we put our x minus 2 right there. We did the process the same way, okay? So I know it looks a little messy. That's just the answer. But I want you to notice, guys, this was the 4th problem. As we've gone through this problem, the process has remained the same every single time, okay? So look, I'm going to kind of skip this one here because it's the same type of problem, but I want to go to this one. The reason I want to go to this one here, if you notice, it's just x to the third minus 1, right? So remember, the numbers that I'm putting here are the coefficients, the numbers in front of the x's. Well, I know the number in front of the x to the third is 1. After x to the third, we normally have an x squared, and after x squared, we normally have an x, and then we have our constant term. Because I don't have an x squared, and because I don't have an x, it doesn't mean that they're not there. It just means that the numbers in front of them happen to be 0. So this here is really the number in front of my x squared, and this here is really the number in front of my x, okay? And I gotta put them there because they're kind of like placeholders, okay? So remember, now what I'm gonna do, I'm gonna look at the bottom part. If it's a minus 1, I gotta change the sign with a positive 1. Okay, so now let's go ahead and remember, first step, bring this guy down. So 1 times 1 is still 1. Add them together, that's 1. Multiply again, 1 times 1 is still 1. Add them together, and that is 1 right here. The last number here, guys, I forgot it. That's a negative 1. And let's see, 1 times 1 is still 1. Add them together, that's 0. That's my remainder, right? That's my remainder right there. So remember what we had. We used to have an x to the third polynomial. We've reduced it by a power of 1. This is now the number in front of my x squared. This is the number in front of my x, and that is my constant term. Okay. So let's see. All right. So let's keep going a little bit because we can probably get through a lot of this kind of business right here, guys, just going through a couple of these problems, all right? And again, I want to at least kind of get you like a head start on this thing here. Okay, so we have something called the special case of the division algorithm, and it says for any polynomial f of x and any complex number k, there exists a unique polynomial q of x and a number r such that the following holds true. And okay, let's see what it's telling me to do. It's telling me use synthetic division to divide f of x by x minus k for the given value of k, and then express f of x in the form, and it's got all this business right here. Okay, so again, one thing I want to point out about this thing right here, I'm going to go back to that same example of taking 9 and dividing it by 2, where we came up with 4, 8, with a remainder of 1, and we said, well, 9 was equal to 2 times 4 plus 1. This is what they're asking me to do for our particular problem here, okay? So I'm going to use synthetic division. I'm going to do my little half box. I'm going to put 2, I'm going to put 1, 1, and negative 8. Now, I want you to notice something here. Do you see how this is in the form k is equal to 1? And if you come back and you look at this business here, or k equals -1, and you look at this part right here, if I were to fill in that number -1 in here, I would have x minus a -1, which would be an x plus 1, right? Excuse me. So in essence, guys, what I'm doing is I'm dividing this by x plus 1. When we divide it by x plus 1, do you remember what we said we have to do with that number? We said, oh, we have to change it. So if I see a plus 1, I got to make sure I put a -1. So before I go on, if I notice in my problem, do you see how it had k equals -1? Well, all that's telling me is that when it's in this form, k equals, the sign has already been changed for me. I don't have to do anything, okay? So I'm going to go ahead and start. I'm going to bring down my number 2, and I'm going to multiply. -1 times 2, -2. I'm going to add straight down. 1 minus 2 is a -1. I'm going to multiply again. -1 times -1 is 1. I'm going to add straight down. That's going to give me a 2. I'm going to multiply. -1 times 2 is a -2. And I'm going to add straight down. That's a -10. Remember, this here is my remainder. Okay? Excuse me. All right. Now, what we're going to do is we're going to write out our answer. Remember how we said we were, in essence, we were really dividing by x plus 1? So I'm going to write it like this. X plus 1 times, remember, this here is the number in front of my x squared. This is the number in front of my x. This is my constant term. And then my remainder at the very end is a -10. So all this is telling me is that, I know I got a little messy here, so I'm going to clean it up for you. All this is telling me is that f of x, which is equal to 2x to the third plus x squared plus x minus 8 is the same thing as this piece right here, okay? If we were to multiply that x plus 1 throughout everything and then subtract 10, we would end up with this guy. That's all that that part is telling me, okay? All right. Okay, so now the next piece here says the remainder theorem. It says if the polynomial f of x is divided by x minus k, then the remainder is equal to f of k. Okay, so it says let f of x be equal to this guy right here. Use the remainder theorem to find f of -3. Okay, guys, everything here in 3.2 is all synthetic division. Okay, so I don't want to lose track of that. -1, 3, -4, -5. Okay, I want you to notice right here, it says f of k. If I look at this guy and I look at this guy here, wouldn't you all agree that my number k is equal to -3? And we said earlier that when it's in the form k equals -3, the sign has already been changed. I don't have to worry about changing the sign. So right over here, I'm going to write the number -3. -1, and I'm going to multiply. So -3 times -1 is a +3. I'm going to add those together. That's going to give me a 6. I'm going to multiply again. -3 times 6 is a -18. I'm going to go ahead and add straight down. That's a -22. And I'm going to multiply one more time. -3 times -22 is a +66. And when we add straight down, that's going to give me a 61. Okay. And it says use the remainder theorem to find f of -3. Okay. What that means is that f of -3 is always going to be equal to whatever my remainder is. Remember, we said the last number, guys, is always going to be my remainder. So in this case, f of -3 is equal to 61. Now, all this has told me for this particular problem was before, prior to what we did today. If I asked you to find f of -3, what you would normally do is everywhere you would have an x, you would plug in the number -3. And you'd have to, plug and chug and do all that kind of stuff. So you would say f of -3 equals, let's see, there's a -3 to the 4th plus, oh gosh, you know what, guys? Oops. Sorry about this, guys. I just realized I made a boo-boo. Okay, and I just caught my boo-boo right now. So, sorry about that, guys. Okay, let me tell you where I made my boo-boo. I don't know if you guys caught it or didn't, but it's okay. Remember we said this is a number in front of my x to the 4th? After x to the 4th, I normally have an x to the 3rd. I didn't fill it in. I forgot. I had to put a 0 there. So that screwed everything up. Okay, that's all right. We'll do it again. So there's the number in front of my x to the 3rd. Here's the number in front of my x squared. Here's the number in front of my x. And here's my constant term. That's okay. The good thing about this is that it's quick. So here's -3. All right, let's bring this number down. -1. We multiply. 3. Add together, that's still 3. Multiply these together, that is a -9. Add them together, that's a -6. Multiply, this is a +18. Add them together, that is a 14. And -3 times 14 should be a -42. Add them together, that is a -47. Okay, so sorry about this, guys. So this is telling me f of -3 is equal to -47. All right. What I was going to say was typically what I would have to do is everywhere I had an x, I would have to plug in the number -3. This is just another way to do it. And if you can see, I made a mistake and I had to go back and do it again. And look how quick it was. It's pretty fast on how to evaluate a polynomial, okay? So same thing is going to apply for this problem right here, guys. It says use the remainder theorem to find f of k. All right, so I'm going to do synthetic division one last time. I'm going to fill my numbers in. So 1, -4, 2, and 1. And remember, it's already in that form, k equals -1. So the sign has already been changed for me, okay? And I'm going to go ahead and start bringing my numbers down. So I'm going to bring down the number 1, and I'm going to multiply. So -1 times 1 is a -1. I'm going to add straight together. That's a -5. Multiply again. -1 times -5 is a +5. Add them together. That's 7. -1 times 7 is a -7. Add them together. That's a -6. Here is my remainder. So all this is telling me is that f of -1 is equal to -6. And that's my remainder theorem, okay? And let's see. Okay, so just a tiny bit more to go, guys. I know we're already past the 7 o'clock in the hour-long thing, but look, we got 2 more problems. And all this says here, for these next problems, it's asking me if these problems are a 0 of the function, okay? In essence, what this is asking me to do is, let's use the remainder theorem. If our remainder ends up being 0, then that number k is a 0 of the function. If not, then it's not a 0 of the function, okay? So it says a 0 of the function f of x is a number k such that f of x equals 0. And it tells me right here, this is important. Real zeros are the x values of the x-intercepts of the graph of the function. Okay, so all we're going to do here, we're going to use synthetic division. I'm going to go ahead and do both these problems, y'all, because they're pretty fast. So here's my half box. Let me fill in my coefficients. So this is 2, -6, -9, and 4. My sign has already been changed for me because it's in the form k equals. And I'm going to go ahead and just start. So I bring down the first number, 2. 1 times 2 is 2. Add them together, that's a -4. 1 times -4 is also -4. And let's see, -9 minus 4 is a -13. So when I multiply 1 times -13, that's a -13. Add these together, that's a 9. Okay, so what we would say here is, let's see, k equals 1 is not a 0 because f of 1 is equal to 9. Okay, and let's see. We're going to do the same thing for the next one. Okay, so I'll go ahead and draw my half box. 1, 2, -1, and 6. Remember, k equals -3. The sign's already been changed for me, guys. So -3. Okay, so I'm going to bring down my number, 1. We're going to multiply. -3 times 1 is -3. Okay. 2 minus 3 is a -1. -3 times -1 is a +3. We're going to go ahead and -1 and 3 is going to give me a 2. -3 times +2 is a -6. Add them together and we get 0. Remember, this is my remainder. So what I'm going to say here is k equals -3 is a 0 of the function f, because f of -3 is equal to 0, right? My remainder happened to be 0. Okay. So anyway, that's 3.1 and 3.2. We were actually able to get through both of them tonight. So guys, I hope that helps. Remember, the videos that I have on YouTube, they're the same exact thing that we did here tonight, okay? What I want to do, guys, is every Monday night at 6 o'clock, I want to do a session like this. And so like right now that we're done, right? In a few minutes, I'm going to sign off. What I really want you guys to do is, if you haven't done your homework yet for 3.1 and 3.2, work them out right now, right? Try to get that stuff done. If you got a question, message me. I'll try to get back to you tonight. If I don't get back to you tonight, I'll get back to you tomorrow morning, and I'll make a video of a problem that, you know, if you got a particular question, I'll make a video, I'll send it out. But the idea is, you know, because I'm going to sign off, I'm hoping this is kind of like, this gave you the warm up and you can kind of finish the workout on your own. Okay, if that makes any sense. So let me stop sharing this. Did you guys have any questions? Did y'all want to ask me about anything? Did that seem to help? Did it seem to make sense? Like, do you feel like you're ready to kind of?
Well, I definitely got flashbacks from 8th grade. No, not 8th grade. No, not 8th grade. Senior year, I mean.
Senior year. There you
in
go.
Calculus.
Good. But I mean, did this help? Like, do you feel like you can get started on this stuff now?
Yes, actually.
Good.
Honestly, I got it pretty well. I don't know about everybody else,
excellent. Yeah. Well, hey, I'm asking you guys individually. Jose Rebelo, so you got your mic on?
Yes, I understand it more now.
Good. All right. So guys, remember, just to give you a heads up, I don't know if you guys are aware of this or not. Next week is spring break. I don't know if any of you are going to go anywhere, but next week is spring break. So a week from tonight, we won't do it, but the week we come back, and I'll send you guys a message, you know, saying, hey guys, I hope you guys had a decent spring break and you're okay and, you know, didn't do anything too crazy. But, you know, in 2 weeks from tonight, we'll do the same kind of thing. And guys, again, if you guys got questions, don't hesitate to ask. You know, I know it's hard to kind of decide, like, hey, you know what, today is Wednesday, I'm going to start doing some algebra today. It's not something that most of us think of, but this is how, you know, the classes in an online setting are kind of set up. You know, message me, guys. Even if it's 4 o'clock in the morning, message me. I'm probably not going to get back to you immediately, but the next day when I wake up, I'm going to see your question and I'm going to respond to you guys. Okay. So you can message me anytime. I actually don't have the apps on my phone. I have them on my, like the Remind and the Pronto. I keep them on my iPad. So if you message me at 4 a.m., I'm not even going to hear it. Okay, so don't worry like, oh, I don't want to message him right now. He might wake up. Message me anytime, okay? And I'll get back to you when I check the messages. But I hope this helped. And like I said, you guys got questions, let me know. And I guess I'll see you guys in a couple of weeks, all right?
Actually,
All
I have
right.
a
How
question
long
about
is spring
homework.
break?
It's a week.
Oh, okay, okay. It's because you said the
Yeah,
next
1 week.
couple of weeks, and I was like,
Well, yeah, like 2 weeks from the night, we'll do this again.
okay.
Yeah. Jose Mejia, you said you had a question for me?
Yeah, it's in the homework.
Yeah,
I mean, I
tell me
got
which
it
one it is.
eventually, but the
Okay.
process it took me to get there is something I'm not too sure we went over. I was wondering
Okay,
if you
which
can go over that
question?
with me.
Yeah, what question are we looking at?
It was for the 3.1. It was
Uh-huh.
question 10.
Question 10. Okay, so give me one quick second. I'm going to pull it up right now. Okay, let me do this. Let me do this. Let's see. Okay. Let me see. Let me just, my computer's loading it up right now. All right, number 10. Okay. Okay. All right, so let me do this. Let me come back to this part here, here, here. Okay, so my problem might be slightly different from yours, but it was this type of problem, wasn't it?
Yeah, it's different, but yeah,
Yeah,
it's the same essence
the
of
same
the.
type of problem, right?
Yeah.
Okay. So guys, what I'm going to do is I'm going to show you guys I'm going to walk you all through the process of doing this problem here, so you can kind of see. So let me see, I'm just going to write something down on my paper so that I can, excuse me, I can use it as I need it. What do we got? We got 4, -2. Excuse me, and we got 0, 0. Okay. So let me do this. Okay, here we go. All right. So in essence, what we had was we had a graph that kind of looked something like this. 1, 2, 3, 4, 1, 2. Graph went through here. Graph went through here. And my graph kind of did something like this, right? And this point here was 4, -2. And that point right there was 0, 0. And it was asking me, can we write out the equation for this graph? And the answer is yes, we can. Okay, so what I'm going to do here, guys, I'm going to use this form, y equals ax minus h squared plus k. So remember, here's my h and here's my k, right? So I'm going to go y equals a, x minus 4 squared, and k is a -2, okay? And then remember, the point that we have on our graph, x and y, is the point 0, 0. So this here is 0, and the x number is also 0, okay? And all I'm going to do now, guys, I'm just going to solve for a, okay? So 0 equals a, let's see, 0 minus 4 is a -4, but that's going to be squared, minus 2. Okay, so -4, when I square it, is going to give me a positive 16, minus 2. Now I need to bring this -2 back to the other side. That's going to give me a positive 2, equals a 16a. So when I divide by the number 16, a is equal to 1 over 8. Okay. So guys, now that we have that part, okay, all I'm going to do is I'm going to use this form right here, And where the a used to be, we're going to plug it in with a 1/8. So y equals 1/8 x minus 4 squared minus 2. Remember we said the graph here is opening upward. So my number a is going to be greater than 0 because it's going to be positive, right? That's what bigger than 0 means. So, Jose, did that make sense on how we went through that one?
Yeah, my only issue was the simplification of the fraction, but I got it.
Okay, good. Excellent, man. I'm glad we're able to go through this one. Guys, do y'all have anybody else got any questions about anything? All right, well, listen, I'll let you guys go. I'm going to go ahead and stop recording. Let me stop sharing. I'm going to go ahead and stop recording this.